It's a pleasure to be here in Korea. It's always been a bit of my dream to feel a little bit like a K-pop celebrity, so thank you so much. Now I feel like I'm achieving my dreams. It's a pleasure to be here to represent DeepMind and our team in London, working on AI research with games. And I'll start by giving you a little bit of background on how I got into this incredible journey of AI research and gaming. It started about 15 years of working in the games industry across a range of different experiences, from casual games as a publisher, producer, but also as a development producer working at Ubisoft on AAA games like Ghost Recon and Watch Dogs, and then also exploring interactive fun experiences with robotics at SoftBank. And 10 years ago, I joined DeepMind to work on research with games. So harnessing the power and the richness of safe testbed environments like Atari and StarCraft to train AI agents to learn how to perform well in these games. And also joined the Gemini project from the very start, driving the data strategy and exploring new capabilities with Project Astra, which was exploring natural language and real-time vision that was powering Gemini today through the Gemini Live API. But our love of games and our deep partnership with game developers continued to start the SIMA project, collaboration with game developers to train safely and ethically AI agents with the permission of game developers with our amazing partners across the industry. And also another research project where SIMA was the agent that we were training, Genie was the world model that was generating environments for research. Today, I'm a director leading our product division in Inception, alongside research exploring breakthrough experiences that wouldn't be possible without AI. Google DeepMind's mission is to build AI responsibly to benefit humanity. And what this means for us is to build AGI, artificial general intelligence that can be trained responsibly and safely to achieve a vast variety of tasks that will transfer to solving real-world problems and benefit communities around the world. And games have always been a core tenet of our research programs because we believe that games provide minimal models from which more complex dynamics can be learned. Across our history, we've been leveraging the complexity and richness of deep game simulations, from Atari to StarCraft in video games, but also Go with AlphaGo and AlphaZero, generalizing what we've learned in tabletop games to chess and shogi. And fundamental breakthroughs that were achieved through these research projects led to other scientific discoveries, such as solving protein folding with AlphaFold. Many of the algorithm discoveries came from these research projects in games, so they're really important to our program and core to our gaming DNA at DeepMind. And the reason why our company has such a deep-rooted history in games is, like myself and many members of my team, our CEO, Demis Hassabis, was a former game developer. He worked in games like Theme Park and Black and White, deep simulation games where AI plays a core role in the gameplay loop, using reinforcement learning as part of the fun experience. Many of us across DeepMind come from a gaming background, and many of the core teams in the studios that Demis worked at joined DeepMind to fund it in 2010. We bring our experience and expertise iterating and creating fun, engaging experiences to our research and the new experiments that we're doing today. There's actually a lot in common between game development and how research works in terms of the workflows and the life cycles of projects. In the context of a game, you come up with an idea, and you're going to iterate and test, build prototypes, try to find the fun. And use all of these iterations, improving your game idea and getting feedback from players until you find something that's truly meaningful to play and scale it to millions of users. In research, we do very similar things. We come up with a hypothesis, a question we want to answer. We build experiments to test our ideas and assumptions, get information, learning, and use this to achieve the breakthrough that we're trying to achieve, and then scale the solutions to millions of users and hopefully benefit and improve their lives. And so in the talk today, I wanted to build on that history of research to share a bit more in depth how we think about games for AI research. And I will start with AI agents that I will define as intelligent entities that perceive their environment in an autonomous way in order to achieve a goal. So the ability to see what's happening like humans would, take real-time actions in order to complete a certain task. Throughout our research history, we've always leveraged games for the complexity and the challenges that we're posing for AI as an opportunity to test our research ideas safely. So in Atari, we have 2D games, and we learn how to build an algorithm that can train across a range of different games and achieve great performance across all of them in a very general way. In AlphaGo, we look at a very complex game where you cannot brute force the result, find the solution just by brute force computing. So we need to come up with new research ideas, new algorithms, and new ways of planning. It's a perfect information game, meaning that you can see everything that's happening on the board and everything that your opponent is doing. And it's a turn-based game, so that means you can pause and think before you act. As we generalize what we've learned from AlphaGo to AlphaZero, removing prior human gameplay data and generalizing to chess and shogi, we've also wanted to challenge our AI agents with real-time environments. This is where this AlphaStar project came up with StarCraft, because StarCraft brings real-time challenges, multiple units you need to control at the same time, and it's an imperfect information game. You cannot know what the opponent is doing behind the fog of war. And so the agents need to imagine what might be happening to make assumptions and derive decisions from that. But also, as the fog of war is revealed and some of the new information is available, you need to adapt your strategy. And so StarCraft was, yet again, providing new challenges for AI research and enable us to discover new capabilities. Once again, following StarCraft, we always want to generalize. We want to build general solutions, not ones that only work in a specific game, because we think this is what DeepMind is best at, focusing on solving root node problems that can have a range of different applications and in gaming and beyond. Following this track record of research in games, we continued to push the boundary and the frontier further of what is possible in games with AI, and continuing to build on the history of long connections between AI research and gaming in DeepMind and beyond, we started the SIMA project. The SIMA project is a research into embodied agents that can follow language instructions in 3D worlds, and we wanted it to be a general solution once again. So we partnered with developers that had very different and interesting games, both different visually and in terms of mechanics or perspective, first person, third person, 3D games in which we could train and test safely the agent with their permission. It was also something that's very dear to our hearts as former game developers and passionate gamers, to demonstrate that there is a way of working responsibly and ethically with game developers when it comes to AI research, and set a precedent for the right way to engage with the community. And it was fantastic to have so many amazing studios join us on that journey, and we hope to continue doing this in the future. A few weeks ago, we did exactly that by partnering with Fenris Creations, the developers of EVE Online, the iconic MMO that is such a fantastic and challenging world for AI research. It's a deep, complex, player-driven economy with hundreds of alliances and corporations engage in collaboration, conflict, trading, but also it's a persistent world. So that means the world doesn't reset, your actions have consequences over long periods of time. So it's a fantastic environment to train and test our research ideas in continual learning, long-term planning, as well as memory and multiplayer interactions between players and agents. We also feel that we're starting to have interesting capabilities in our AI models today, even if they're still at the frontier, at the early research stage. We want to explore what it might look like to leverage some of these to create new experiences, things that wouldn't be possible without AI. And we'll be partnering with Fenris creation teams, amazing developers behind EVE Online, Vanguard, and Frontier to explore what these new experiences might look like in the future. Before I show you a little bit what it looks like when Sima controls an agent and the main avatar in our partners' games, I just wanted to show you what it looks like from a research and infrastructure perspective. Sima sees what the player sees, only gets the pixels that are on the screen, and it puts exactly what a player would input, keyboard and mouse actions. So our setup is simple. The player or user will input a language query, a simple phrase of something that the player would want the agent to complete in the game, without necessarily knowing anything specific about the game or the right words, to just plainly speak in natural language. This text is inputted into the agent that looks at the pixels on the screen and performs actions on the keyboard and mouse to achieve this task. And so what the example shows here, enter the spaceship and fly away, shows what the agent does as it controls the main player, and you can see on the keyboard the actions that the agent is taking in real time. I'm going to show you a video where in every single game here, Sima is controlling the main character. With Sima, we believe that the fundamental discoveries that we can make in 3D worlds will transfer to the real world and potentially to robotics. So we treat gaming research as a fundamental tenet of our research program, and it's a fantastic way of doing research safely in partnership with game developers. And because we always try to build a general solution, testing what Sima can and cannot do across a range of games is the best test of that reality. Agents is one side of our research program. Entities that can take actions based on the perception and the reasoning that they do in real time in the world. The other side are world models. World models are systems that can simulate the dynamics of environments, meaning they can understand deeply what is the causal effect of actions and reactions in the environment in order to simulate what it might look like as users or players take actions. This is an even more kind of earlier stage research stage that agents might have been, as we've been doing research for many years. But it's a very exciting component as it adds and completes our research flywheel, where we can now train and test AI agents in worlds they've never seen before. We believe that Genie is this next generation in world model research and really the frontier today. I want to take you through that journey from Genie 1 in February 2024 to Genie 3 last August. And only this kind of incredible progress made in just 18 months. There's still a lot of research ahead, still many things to discover. But I want to show you what we're starting to see unravel and that journey that we went on and where we think the trend is continuing. Let's jump back to February 2024 when we published Genie, Generative Interactive Environments. We see this as a new class of generative AI, where not only can you generate frames, but you generate them in an interactive way as a response to the user's actions. Genie was very humble. It was very much the first steps. It was also a moment where we had a proof of life that our research idea had potential, and we demonstrated this with these simple, short 2D clips where the player is controlling the character you see on the screen. They were 2D and limited, but they were an important breakthrough for us, demonstrating with this proof of life that there was a new research avenue for us to explore. So what could Genie do? Genie fundamentally demonstrated that you could learn a range of actions possible within a context of a video without having any instructions or action labels, annotations about what the right actions would be. And we trained Genie only on videos of these 2D platformer games that you've seen, about 30,000 of them, publicly available internet gameplay videos. And for the first time, we had a proof of life that we could build a kind of prompt-to-world generative class of models, which from a simple text prompt or a single image, you could start to generate interactive environments. The interactivity is key because, remember, from a research standpoint, what we want to do is to be able to train and test AI agents safely in these virtual environments generated on the fly. So it's important that the agent is able to control these environments, take actions in them. So interactivity is key. And so we built, for the first time, a generative model that can generate very simple environments where the main character can be controlled by an agent. But of course, it was only the beginning, with much research ahead. It had very short memory. It was limited to just 16 frames. It was also limited in terms of frame rate. It was generating 1 frame a second. So you get this kind of, at best, 10 to 16 second clip of 2D. So, of course, a lot more is needed. And also, fundamentally, we were discovering and going deeper and deeper in our research on autoregressive transformers, which are prone to visual artifacts and often displaying things that either are not present in the frame before or making existing elements disappear a few frames down the road. So much more research was needed, but we found an interesting pathway and an interesting breakthrough with Genie that we carried on working on, until we released our paper on Genie 2 in December, so just about 9 months after Genie 1. We moved from only 10-second 2D environments to a variety of fantasy 3D worlds, very diverse and rich in color and dynamics. And for us, what Genie 2 was proving was this ability to scale up our approach to produce richer and interactive 3D environments, still from a single prompt image. We remain the action controls, but they're also more diverse than only what we can do in 2D, because now you can navigate in a 3D world. We get a slightly longer horizon memory. We go from a few seconds to multiple minutes, but most importantly, what we get is the agent, the world model, sorry, keeping in memory what was present on the screen when it's certainly off screen. We can also now do it from different perspectives, first person or third person, but also isometric perspectives, and not only 2D. And most importantly, the worlds are a lot richer. The dynamics and the physics of these worlds, the fundamental dynamics that we're trying to learn, start to come across in these generations. Lighting, gravity, reflections, and all sorts of other complex dynamics that are really hard to simulate now start to emerge. So we're really happy with the progress that we've made on only just 9 months from Genie 1 to Genie 2. But again, there are some core limitations and more research is needed. Most importantly, the generation length is not sufficient. We feel like while we have scaled tremendously from just a few seconds to a minute or so, we start to see degradations of the quality of these generations. And after, even from as early as 10 seconds, some elements start to degrade. We get about a minute of continued interaction before the world has melted away and doesn't look anything like what you generated at the beginning. But most importantly, as I mentioned earlier, we want the agents to be able to interact in real time. Because the world is in real time, that's the challenge we're after. However, while we managed to get some real-time distilled version, our main model wasn't fast enough. And when we distilled the model, while we get real-time interaction and generation, we do lose a lot in quality. And so there's clearly a trade-off, which is typically what you see between video generation models that can be extremely high resolution and interactive models like Genie. There's the trade-off between the real-time interactive aspect and the quality of the generations. You can get much better quality without interactivity, but for us, that's the breakthrough we're after with Genie. And so in August 2025, we introduced Genie 3, again, just about 9 months after Genie 2. An incredible, fast-paced approach to this research program that led to fundamental breakthroughs that we were really happy with. And in particular, our ability, after going from 2D to 3D worlds, to now go from fantasy worlds only to fantasy and photorealistic environments in real time. And still only from single text descriptions, we get this variety of environments that are keeping very precise and complex simulations like physics and lighting present, and real-time interactivity on top. So finally, we're there. With Genie 3, we have a model that is capable of generating frames at 24 frames a second, and it allows for real-time interaction of agents. We also get photorealistic renderings up to 720p. And now we are starting to make good progress on world consistency. While it's still limited in time, we get from a few seconds to multiple minutes where we maintain strong consistency of the world and keep a good memory of everything that happened, but also what the user has changed in the world. We also discover and introduce a new capability, which we call promptable world events. This is effectively prompting the world after the generation has started. So when you generate a Genie world, you describe what you want it to be, you can add an image as a reference, and the world is generated. As you take actions in the world, new frames are generated. But what about if you wanted some event to happen that might not be related to what the user has done after the generation has started? Let's say you wanted some event to happen, something to fly in, or characters to show up, or some narrative event that you'd want it to drive, you'd need this ability to script these events as you would do in a video game. And so we think of promptable world events as this ability to drive the simulation and direct it by injecting prompts while the generation is happening. Again, very early kind of frontier capability, but we had the beginnings of something that we felt will give more control to the kind of worlds we can create in the future. I'm going to show you a video that describes the different things that we've discovered that I hope will illustrate some of these capabilities and also the potential of this in the future. The images you see here are not video generations. They're Genie generations. That means from a text image, you get this generative world that responds to the user's actions. On the left is a simple sentence that gives a rich, photorealistic environment where you control the main character. And this works across a range of different environments. You can not only create different photorealistic environments, but you can control them. So now you're in real-time control of the world, but you also want it to stay consistent. You want the world to remember what happened. And so world memory allows you to do that. Everything that was generated during this few minutes stays there, including, for the first time with Genie, keeping memory of the actions taken by the user or the agent. So if I draw something on the wall like this, and I look away, you'd expect this to still be there and not be forgotten by the world model. We also start playing with promptable events. So the generation is happening, keeping the same consistent environment, we can introduce events to the world. We can simulate different types of physics, from water simulation to wind. And again, very complex things to simulate in traditional simulation start to emerge. And again, remains general, works across fantasy worlds and realistic worlds. And while we're really excited about gaming, we also see how these simulations can be fantastic test beds for training and education, for testing difficult scenarios to replicate in the real world. And we're excited to see how this can unlock a range of different applications in learning, in entertainment, and in AI research. And while the Genie is still a frontier research model, we are extremely excited to see the incredible progress that's happening just under a few months between Genie 2 and Genie 3. I didn't even have the time to finish the sentence that Genie 2 already gave up generating. Genie 3 carries on, much longer, much crisper, and with a lot more consistency. And while it has some limitations, the difference between the two is stunning, and it's only 9 months that's separating the two. So we're excited about the next generation of Genie research and world models progressing in more complexities of the world, more richness of interactions, and unlocking new capabilities in the future. But what kind of research do we have ahead? Now, while we have real-time interactions, which was the key breakthrough for us, we want the interactions to also be more complex. Today, you can navigate the world, you can do a few sets of limited contextual actions, but if we want agents to be able to learn a range of different things and people to interact with these worlds and enjoy them, we want to give as much autonomy and freedom to do a range of different things. We need more actions. So growing the latent space of actions is going to be a fundamental focus for us in the future. But also, the world is not single agent. We want multiple agents, multiple characters to be able to interact in these worlds. We've done some early proof of concept in this space that we mentioned briefly at Google I/O this year, our yearly conference where we share our progress. But this is still a very early research stage and a deep research challenge. So multi-agent interactions is also going to be a fundamental focus for us in the future. In addition to generating the environments, we want everything that we know can be generated in image generation and video generations to graduate to world models. Things like clean and readable text. Unless it's in the prompt today, we find that world models are struggling in generating them purposefully and correctly in the world, and we want to improve the crispness of text rendering as well. With Sima, our most general agent, and Genie, our most general world model, we now have the two pieces of our AGI research flywheel. A cyclical process where AI agents can be trained in world models safely and help improve the world models. So effectively what this means is Sima generating actions that are responded by Genie in real time. So you take a Sima agent, drop it in a Genie world. Here what you see is a Genie environment. So what that means is that Sima could not have seen this world before. It's generated in real time as Sima takes actions. Because it hasn't seen it before, this is the ultimate test of Sima's ability to generalize. And as it discovers issues with the world, it helps us collect data and feedback on how to improve Genie and improve the world model generation. And so this feedback loop between models and world models, agents and world models, is our AGI research flywheel and is a safe way of accelerating the research that we're doing in this space. Before I conclude this talk, I'd like to leave you with some thoughts about the other side of this coin. I talked at length about games for AI research. I want to touch on what AI research could do for games. We've been privileged in working with amazing game developers from Hello Games, Coffee Stain, and recently Fenris Creations. And we look forward to continuing doing this in collaboration with game developers to set the right ethical and correct way of doing AI research in games. And we think this is the right way of safely advancing AI research. But I want to leave you with a thought about the future of AI research for games. Can we start exploring how these new capabilities can unlock new player experiences, breakthrough gaming experiences and emotions that wouldn't be possible without AI? And if we do this, we should treat it as a research discovery. In the same way that we would treat any concept idea in a video game to iterate to find the fun. To not assume that any or all of these AI capabilities put together would necessarily lead to a fun experience, but treat it as a question, a hypothesis, an idea to test and to iterate on until we find the fun. And if we are to progress the community and research and new gameplay experiences, to do it in an honest and pragmatic way by showing rather than telling, by creating examples of fun experiences, prototypes to share our discoveries with our colleagues and the community of other game developers to inspire the whole games industry to explore new experiences and to share them with the world. With that, I would like to thank you for your time. It was a pleasure to join NDC this year to share some of our work, and I'd be more than happy to take a few questions.